Hey guys, welcome back. So this is Murthy again from Manifold AI Learning. Now continuing in the learning journey of this linear algebra for data science, today let's see what are the various statistical operations that we can perform on this NumPy array object. Now to explore the same, here I have created a NumPy array object. So this is a matrix that I have created. This is a two-dimensional array. As you can see, I'm having the shape of 3 by 3. That means 3 rows and 3 columns. Now the first function that we are going to say is how to find the mean. Now to find a mean for an array object, we can just make use of np.mean function. So np.mean, and inside the parenthesis, just specify the matrix onto which you want to find the mean. So I'll just execute this. So I'm having the output as 5.0. That means it's a mean of 5. It has summed up all the elements that are present in this matrix and it has divided by number of elements that are present in this matrix to return me the mean of those elements, that is mean of this NumPy array object. And if I want to find the variance, then I can find the variance by making use of var function. So np.var. So this is going to return me the variance of all the elements that are present in this NumPy array object. Now coming to standard deviation, to find the standard deviation, I can simply make use of this function of np.std and this would return me this standard deviation for the elements that are present in my NumPy array object. Now the best part is, while working with this NumPy array object, I can find and I can apply all this statistical function along the required axis. Now to tell you what I mean, here if you look at it, I'm calling it as np.mean and I'm specifying the axis onto which I want to perform this mean operation. So np.mean, and if I just execute this, this has written me the mean of the elements across the axis is equal to 0. Now suppose if I call it as np.mean and axis is equal to 1, then this would return me the mean of elements across the axis is equal to 1. Okay, now you can verify the same. See, I'll display my original matrix. My original matrix has the elements as 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's do one thing. Let me find the mean column wise. So I'll select the column. So let's see, this is the column that we are considering. So let's do the sum. Sum means 1 plus 4, that is 5. 5 plus 7 is 12. 12 by the number of elements, that is 3. So 12 by 3 is 4. So where do we have 4 over here as the first element? Yes. See, if I call as axis is equal to 0, it's going to perform the mean or any other operation along the columns. And if I give it as axis is equal to 1, it is going to perform the operation row wise. Okay. Now this concept of applying the axis, it applies to other functions as well. So I can call np.std and I can also specify the matrix as a first argument and I can also specify the axis onto which I want to perform this operation. So axis is equal to 1. See, this has performed this has found the standard deviation for this matrix object along axis is equal to 1, and I can do the same for axis is equal to 0 as well. Okay, now let's do one thing. I'll select this function and let's open up the documentation. Okay, I'll open up the documentation and you could see what are the various parameters that I could use when I'm calling this np.mean function. So the first element is a, which is an array, and the second parameter is axis. So we have explored how it should work, and we also have an optional parameter as d type. Now using this, I can specify what is the data type. And we also have one more parameter called out. So let's see what is that out would mean. So out would mean that it's an alternate output array into which I want to place the result. So by default it is none, and if I provide something, it is going to assign all those values to it. Okay, so if provided, it must have the same shape as the expected output, but the type will be cast if necessary. Now let's do one thing. Let's explore this function. Okay, I'll create a NumPy array object. Let's say I'll say it as output, and I'll say it as np.array, and I'll create it as a blank array. Okay, I'll create it as a blank array. Now what I'll do is I'll find the mean of this matrix. Okay, I'll find the mean of this matrix. So np.mean matrix. And after I find the mean of this matrix, let's say I want to find the mean across a specific axis. So axis is equal to 1, and this time I'm going to say that out is equal to output. So I'll copy and paste over here because this should be executed after I have created this array object. Okay, now I'll just execute this. Alright, so can you see I'm getting an error. The error says operands could not be broadcast together with the shapes of 0, 1 and 3, 3. So what it actually means is, if you had observed the documentation, it mentioned that if I'm assigning the output, so observe here, if I'm assigning the output, then it should have the same number of elements that is present in my original matrix. So let me do one thing. I'll say it as np.zeros. Okay. And I'll specify the shape as, let's say 3, 3. Okay. And now if I execute this, see, this time I'm getting an error. The error here again, it says output parameter for reduction operation add has too many dimensions. So that means this is very important, guys. If you are using this out function, you have to make sure that the number of elements that you will be getting as an output, so it should match the dimension, or it should match the dimension for the variable onto which you are assigning the values. So this time I'm changing my output to be equal to np.zeros3. And now if I do it, see, I'm having the output, and if I display the output variable now, this has the output as 2, 5 and 8. So you have to be very careful when you're making use of this out parameter. So whatever the output that you're getting as a result of performing this mean, standard deviation and all those operations, all those output array should be matching with the variable onto which I'm assigning those values. Okay, so it should match my original matrix or this original array object. It should match the output array object, else you're going to get the error. I hope this video has been helpful to you, and I'll see you again in the next video. And in the next video of this series, I'll be explaining you as how you can reshape the array and how you can play around with the various shapes of the array. So I'll see you in the next video, guys. And please don't forget to subscribe to my channel.